This is our layout for the design simply supported beam 12 AB for the first floor. For the beam size, we use 250 mm times to 500 mm. Next, for the finishes, 1.5 kN per meter square, and then for the QK, 1.5 kN per meter square. For the deflection, percentage of required tension reinforcement we get 0.001. Difference reinforced ratio we get 0.005. So the formula that we use is P less than P naught, and the answer that we get is 176.5. Next, modification factor for flange with 0.8. Modification factor for span less than 7 meter we use 1.0. Next, allowable span effective 211.8. Next, actual span effective 7.0. So the answer for the beam is okay. For the cracking, limiting crack width we use 0.3 mm. For the steel stress, 285 Nm square. For the bar spacing we get 76.5 mm less than max allowable bar spacing, which is 100 mm. This is our detailing for simply supported beam. This is our layout for designing continuous beam 3/4 AD. For the beam size, we use 250 mm times 500 mm. For the finishes, 1.5 kN per meter square, and for the QK, 1.5 kN meter square. For the reflection, percentage of required tension reinforcement we get 0.001. Difference reinforced ratio we get 0.005. So the formula that we use is P less than P naught. The answer that we get is 229.5. For the modification factor for flange, we get 0.8. Modification factor for span less than 7 meter we use 1.0. Allowable span effective, we get 275.4. The actual span, we get 8.91. Less than allowable span. Now for cracking, limiting crack width, we use 0.3 mm. For the steel stress, we get 298 Nm square. Bar spacing that we get is 76.5 mm less than max allowable bar spacing, which is 150 mm. This is our detailing for continuous beam.
This is my layout for the design beam 2AC. The dimension for slab thickness is 150 mm and beam size is 250 and 500 mm. The characteristic load, which is finishes 1.5 kN meter square and variable QK 1.5 kN meter square. Next, we move to deflection. The percentage of required tension reinforcement is 0.003 and P naught is 0.005. So we use formula P less than P naught. So the answer is 32.1. Modification factor for flange width is 0.8. Modification factor for span less than 7 meter is 1.0. Calculate the L over D allowable is 70.98 and actual span effective depth is 8.42. So the value of 1 over D actual less than 1 over D allowable. The design is okay. For cracking, the limiting crack width we use 0.3 mm. Steel stress is 289 Nm square. Bar spacing is 76.5 less than maximum allowable is 100 mm. Okay, this is our detailing for simply supported beam. This is my layout for the The dimension for slat thickness is 150 mm and beam size is 250 times 500 mm. The characteristic of load which is finishes is 1.5 kilonewton meter square and QK is 1.5 kilonewton meter square. Next, we move to deflection. For the percentage of required tension reinforcement is 0.002 and P naught is 0.005. So we use formula P less than P naught. So the answer is 76.88. For the modification factor for flange width is 0.8 and the modification factor for span less than 7 is 1.0. So we calculate the L over D allowable is 92.26 and 1 over D actual is 10.04. So the value of 1 over D actual less than 1 over D allowable. The design is okay. For cracking, the limiting crack width we use 0.3 mm. Steel stress is 269 Newton mm square. The maximum allowable burst spacing is 150. The spacing is 76.5, less than 150 mm. This is our detailing for design bin E to A5.
So my name is Ahmed Binatupi. So this is my layout. So I will calculate the simply supported beam for C to D roof beam. From that, we got the specification about finisher ceiling, density of concrete, variation, slat thickness and beam size is 250 and 500 mm include the slat thickness. Because of this beam is a roof beam, so the QK is 2, follow the Europol table. Okay, we go to the deflection. So the first is we need to calculate the percentage of required tension reinforcement. This one 3. And after that we need to calculate the reference reinforcement ratio P naught. And the last is the percentage of required compression reinforcement P prime. So when P less than P naught, we need to use this equation by Purdue. So we get the result is 90. After that, we need to calculate the modification factor for flange width. So we use the 0.8 and modification factor for less than 7 meter. So we use the 1.0. So the last is modification factor for steel area provide. So as proof over the S required. So I get the result is 1.1 less than 1.5. And for the actual span effective depth, ID actual is less than ID allowable, so it means okay. For the cracking, limiting cracking width, we use 0.3 mm. So for steel truss, we got 252.5 Newton per mm. So max allowable bar spacing, we use 100 mm. When we calculate the bar spacing, the S is less than 100 mm, so the result is okay. So this is detailing for the beam simply support C to D. Okay, for the first, we use H6 100 spacing for the maximum bar spacing. So the center is H6 175 millimeter bar spacing. This is for minimum length. So the last is for the H6 100 millimeter spacing also for the maximum bar spacing. So for the continuous support beam, I calculate the beam for A to D. So this is my layout. So the dimension also same for the simply support. The QK also same because the location is located at roof beam. For the slat 34 AB, we got the two the result P less than P naught. So we use the formula for ID that I show in the slide. And after that, we need to calculate the modification factor for flange. We need to more than 0.13, so we use the modification factor for flange is 0.8. For the modification factor for span less than 7 meter, we use 0.1. So modification factor for stick area provide as proof over asterisk we got the 0.5. Therefore, the actual span effective depth for the ID actual less than ID alone. So the result is okay. For the cracking, limiting cracking width max we use 0.3 mm. For the stress we got 270 mm square. So the max allowable for bar spacing we use 150. The bar spacing is less than maximum allowable bar spacing. So the result is okay. So this is detailing for the beam 4A and for the beam A to B we use 2H16 on the top and 2H10 for the below with the link H6 300 link spacing. For the beam B to C we use the bar 2H16 on the top, 5H8 for the below, and the link is for H6 150. For the beam C to D, we use the bar for the 2H16 on the top, and for the below we use 4H8. The link we use for the beam C to D, we use H6 300 spacing.
Okay, this is my structure layout for my beam, which is beam 480 at the first floor beam. So we go to the dimension. The dimension for the slab thickness is 150 mm. For the beam size, 250 times 500 mm. The finishes is 1.5 kN per meter square, and for the variable QK 1.5 kN meter square. And we use for the main bar is 25 mm, and for the link is 6 mm. Next, I want to present about the deflection checking for my design before. So the percentage of required tension reinforcement is 0.02. The reference reinforcement ratio 0.05, and we got percentage of required compression reinforcement is 0. So based on the deflection checking for my design, I got allowable span effective depth ratio is 70.98, and the actual span effective depth is 8.4, which is the actual span effective depth is below the allowable span effective depth ratio. So the design will be okay for the design. Next, for the cracking, we use limiting crack width. The max is 0.3, and for the FS we got 273 Newton per millimeter square. And for the max allowable bar spacing we use 100 mm, and for bar spacing we got 76.5, which is below the 100 mm, which is the max allowable bar spacing. For the detailing, we use the main bar is 3H25, and for the link we use 2H6, and the spacing is 150, and for minimum links we use H6, and the spacing is 275. Okay, this is my layout for continuous beam 2A 5D, which is at the ground floor, and with the dimension we use same from the simply supported, which is 150 for the slab thickness. For the beam size, 250 times 500 mm, and for the characteristic load, for the finishes 1.5 kN per meter square, variable QK 1.5 kN per meter square, and for the bar also same, which is 35 mm for the main bar, and for secondary bar 16 mm, and for the link is 6 mm.
So this is my deflection checking for the continuous beam. So we check at the span AB, the percentage of required tension reinforcement we get 0.002, for the reference reinforcement ratio 0.005, and the percentage of required compression reinforcement we get 0. Okay, for the factor for structure system, we use K equal to 1.3, which is for the continuous beam, and we got this calculation is 76.88. So based on the deflection calculation, we got for the deflection is the allowable span effective depth ratio we got 92.3, and the actual span effective depth we get 10, which is the actual span effective depth which below the allowable span effective depth ratio, so the design will be okay. Next, for the cracking, we use also limiting crack width Wmax is 0.3, and for the stress Fs we got is 2.4 Newton per millimeter square, and the max allowable bar spacing we use 150 millimeter, and for bar spacing we get 76.5, which is below 150 millimeter, so the cracking will be okay. So for the detailing, we use same bar for the all beam, which is 2H25, and for the secondary bar we use 2H16, and for the span AB we got the link is 16 times H6, and the spacing is 275, and for span BC we use link also H6, and the spacing 275, and number of link is 8, and lastly for the span CD we use H6, and the spacing is 275, and the number of link is 18, and also we use for the CD we use H6, and the spacing is 200, and the number of link is 3.
For my simply supported beam ground floor, for the dimension is the slab thickness is 150 millimeter. The beam size is 250 times to 500 millimeter. For the characteristic load, finishes is 1.5 kilonewton per meter square. Variable QK is 1.5 kilonewton per meter square. We assume that the main bar is 20 millimeter and the length is 6 millimeter. For the deflection, percentage of required tension reinforcement, we get the 0.007. Reinforcement ratio equal to 0.005. Percentage of required compression reinforcement equal to 0. Factor for structure system, K equal to 1.4. For the factor for structural system before, we follow the formula and we get the 14.81. The multiplication factor for flash width is equal to 0.80. Multiplication factor for span less than 7 meter is 1.0. For the cracking, limiting cracking with Wmax equal to 0.3 mm. For the steel stress Fs equal to 265 Newton per millimeter square. For the detailing, we use the 2H25, and the link is H6, and the spacing of the link is 150. For the maximum spacing we use is 339. This is my continuous view for the first floor beam. For the action on step, for the GK, I get the 5.25 kilonewton per meter square. For the QK, I get the 1.50 kilonewton per meter square. Action on beam, for the beam step width, I get the 2.19 kilonewton per meter, and the brick wall 7.2 kilonewton per meter square. For the reflection, we need to check at span A to B, and the P we get the 0.002, the P naught we get the 0.005, and for factor for structural system, K equal to the HC, and the spacing is 125, and it is same with the other side of